Hello and welcome to this section of the MATLAB tutor. Here we're going to begin to talk about variables. Honestly, variables is probably one of the most important topics that we're probably ever going to talk about this early in the course, because what you'll find is that as you start using MATLAB, you're going to start using variables almost immediately, because this is a powerful environment. You're not always just going to use it to calculate quick answers to fractions. You're going to be defining variables, using those variables in subsequent calculations, plugging those variables in other functions. Later on down the road, we'll be defining our own functions with variables. So variables are really important. Fortunately, variables in MATLAB are super easy, to deal with. So, for instance, if I wanted to calculate, or if I wanted to create the value x, or the variable x, and set it equal to 3, I would literally just type x is equal to 3 and hit enter. Whenever I hit enter, MATLAB tells me, yes, you're correct, x is equal to 3. This means when it echoes it back to you, this means MATLAB has stored the value of 3 in the variable x, and that forevermore is going to contain that value. And notice that whenever I type that in and press enter, up pops the variable x in our workspace, and the value is equal to 3. Right? So if I go and just type x into the screen and hit enter, MATLAB is going to return with the value of 3. So that's what's stored in that spot. All right. What if I wanted to type something like y is equal to -1? Of course, MATLAB totally understands negative values. So I hit enter. Y is indeed equal to -1. That means the assignment has been done. MATLAB stores the value of -1 into y over here as well. And even when I clear the screen, CLC, even when I clear the screen, that has nothing to do with these variables that have been assigned. Clearing the screen with CLC just basically erases what I've written here. The value of the calculations I've done, they always remain, basically. All right, so I know that I have a value in x and a value of y, and I could do things like x plus y. And I could just hit enter, and I can get that result. Right? It's going to add those two things together. I can do x minus y, and I'm going to get a number back in all these cases. I can do things even weirder, like x minus 2 times x minus x squared, right? So I have a y here, y minus 2x minus x squared, and if I wanted just to wrap the whole thing in some parentheses, say, okay, that's the numerator of a fraction, and I can divide that by y, then I'm going to get a value, right? It's going to take all these numbers, calculate the numerator, divide by the calculation of the denominator. Now, this surely does beat typing all the numbers in here. It looks cleaner, and in many cases, you're going to need to do this to get the answer. Notice now that whenever, I didn't assign a value to another variable here, so it just says ANS, answer is equal to 16, and so it updates the value of the last answer equal to 16. Now, I want to make sure you understand that these variables are case sensitive. In other words, little x is not the same thing as capital X. In fact, if I do capital X is equal to 6 and hit enter, then it's going to say, okay, variable capital X is equal to 6. And notice in my variable window, capital X is 6 and little x is 3. They are completely different things. Just completely erase from your mind that these are both x's. This large X is totally different. So I can do things like capital X minus little x if I want to, and get a number. Now, this would be kind of dumb to do in your actual project, whatever you're working on, because it's going to get confusing. Capital X and little x. I'm just merely trying to let you know. A lot of students, let me clear the screen. A lot of students will have a variable y is equal to -1, and they'll try to use y in a calculation, y plus 1, and it'll say undefined variable y. And you'll stare at it and you'll be like, what's going on? Why is it undefined? It's right here. It's -1. You need to know that this little bitty y is different than the big Y. MATLAB doesn't know what big Y is equal to. All right? So we have values for x and y like this in capital X. And we can, if we'd like, we can assign calculations of those variables to other variables. So I can say z is equal to x plus 2 times y. So what this is going to do is it's going to take x and add it to 2y, where it's going to use the values of these variables that we have. It's going to get the answer, and it's going to store it in a new variable that I have created called z. And it's going to give me the value of 1. It's going to say z is equal to 1, and it puts the new variable into the variable window, and we call it 1. We can go nuts with this. We can say w is equal to capital X minus y squared, minus little x if we want to, because we remember in this case we have a little x and a big X. Now we're doing this and we're assigning it to something we've never used before. And so it's going to say w is equal to 2, and it's going to put a w over here and say that it's equal to 2. So anytime you create a variable, r is equal to something, 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 it's going, if r does not already exist, it's going to create r, and if r already does exist, it's going to overwrite the value. So if I say z is equal to 94 minus x, then we're going to change the value of z from -1 to 91. All right, so you can see reflected up in this upper right hand corner how your variables are changing as you do the calculations. And if you create new variables that haven't been used before, it's just going to create a new one here, and you can create as many variables as you want. All right, so you can do some neat things with this. You could say, if you had to do some calculations, you could say 3 to the power of y, right, plus x, let's say, to the power of 7, plus, let's say, w plus capital X, let's say. So this is a little bit more of a complicated calculation involving several of the variables that we have, involving exponents and everything else. MATLAB totally understands all this stuff, and it's going to give me an answer. In this case, the answer is large, so it expresses it as scientific notation, 2.1953 times 10 to the 3. So shift the decimal 1, 2, 3. It'll be 2,195.3, right? So that's what's going to go on there. Now let me show you. I'm going to clear the screen. Your variables do not have to be one letter long. I mean, that would be make for a pretty boring thing. We've already kind of introduced this. Let's say you're doing a simple problem and you know the mass of a block is equal to, 37 kilograms or something. You don't type the units in MATLAB, you just assign the mass is equal to 37. Notice this is a string of letters. We call it MASS, mass, something easy for me to remember. Hit enter, and it's going to create a variable mass is equal to 37 and put it over here in the variable window. All right, I can also define, let's say, the acceleration, 9.8, let's say that's 9.8 meters per second squared. And so I can assign this guy, and I get 9.8, just echoes it back to me. And notice now that mass is in the variable window and acceleration is in the window there. All right, so what I can do is I can say force is equal to mass times acceleration. This should look familiar to you, right? F is equal to ma. Now, if I hit enter right now, it's going to calculate the answer and it's going to stick it on the screen. Now, let me show you a trick. It's not really a trick. It's something I want you to understand. And I've mentioned it once before. If I put a semicolon at the end of any line in MATLAB, what it's going to do is do the calculation, but it's not going to echo it back to the screen. It does calculate ma, mass times acceleration. It does put the value into this variable, but the semicolon says don't print it to the screen. All right. Notice my force variable was created and the value was put here, so you can still see the value of it over here. It just doesn't clutter the screen. This is useful when you're doing, intermediate calculations and you don't want to clutter up the screen. If I want to know what the value of the force variable is, I just type force, hit enter, and there you go. A good example of when you might want to do that. Let's say you're calculating the area of a circle, pi r squared, right? Let's say you're doing that. So let's say first I define r is equal to, 3, right? If I hit enter now, then I'm going to have r is equal to 3 come up on the screen here. And if I hit, if I want to do the pi r squared, I'll say pi times r squared, like this. And it's going to give me the answer. So this works great, but it might work a little bit better to clean up the screen a little bit if I don't echo this first statement back to the screen. So let me clear the screen, right? What if I do it like this? R is equal to 5 and hit semicolon, and then I have, let's say area is equal to pi times r squared. And I'm going to hit semicolon. So now it executes both lines. The radius is equal to 5. The area is equal to pi r squared. All right, so I've done all the math, but I just haven't cluttered up the screen with all of those little intermediate echoes back to the screen. Now, if I want to know what the area is, I can certainly type area and get 78. Of course, it tells me over here the area is equal to 78. All right, now I'd like to close this section with something that I want to teach you just in case you're using a really old version of MATLAB. In this version and in most recent versions, you can see all of the variables here. You can see which ones they are, if they're symbolic or not, and you can see the values here. And if it's a matrix, it'll tell you more information and so on. But there are some command line things you could do. If you want to know what variables are currently being used in your session, you can type who. It's kind of like, hey, who are the variables out there? You type that in, hit enter, and it'll say your variables are. and it'll list them here. It doesn't tell you anything about them. It just says, here's what they are. You can get the same information by looking at this. Now, let me clear the screen. If you type whose, it's a command that basically says, give me more information about all of my variables. And it tells me, all right, capital X, one by one, which don't forget, everything in MATLAB is a matrix, right? So this is like a one by one matrix, one element, right? And here's how many bytes this guy's taken up, and it's a double precision, which means it's a decimal. Remember, double means decimal when you're talking about MATLAB. All of these things are decimal. In other words, I don't have any symbolic variables. Acceleration, again, it's one element, it's a double, and so on and so on and so on. Now, if I create a symbolic variable, which we'll do in the next section, and then I look at the list, then I'll see that some of the symbolic ones are not going to say double; they're going to say symbol. All right, so that's something that you're not going to use that much because you really have that information here, but it's something that you might need to know. So one last thing I'd like to tell you before we close the section. Notice that we did mass times acceleration, and we got an answer. Of course, it's up here on the screen as well in the variable window, 362.6. So you might accidentally, if you're sleep deprived, type in mass times acceleration like this, and you're going to say, hey, it's undefined. What's going on with acceleration? It's right here. Again, when you have capital letters, be careful. MATLAB thinks that this variable, ACCEL, is completely different than this one because there's a capital letter involved. So if you ever get an undefined variable that doesn't seem to be right, go back and make sure that you spelled it right and that you've capitalized it correctly, because 9 times out of 10, that's going to be the issue.